Yes, so let us start session. So previous classes day 1 and day 2. Day 1. Yes, all introductions discussed here. Just about myself, about your course, about course content. Yes, and all this just introductions only explained here. Only introductions. Okay. Yes. So all the introductions, I think not necessary to repeat today once again because same old students only joined here. So about myself, 20 plus years of experience as a Java full stack developer. Just review little bit. 20 plus years as a Java full stack developer. Yes, current working company. This is now presently my designation principal Java full stack developer. Yes, about your course, it's a core Java. After finishing core Java, you can start. Yes, after finishing core Java, you can start full stack. Advanced Java. Yes, frameworks and all that you can start after finishing core Java. Yes, duration 75 days. This is 7 to 8:30 p.m. So next week onwards, I'll make it 8 p.m. From Monday, it's 8 p.m. because many students are asking to change time to 8 p.m. Some delay asking because someone is working. Some working is asking to start at 8 p.m. So next week, I can make it 8 p.m. Okay. So Monday to Saturday classes, daily recordings, sharing to your Gmail ID, 3 demo classes. So 3 days you can attend free of cost. Then you can decide. Yes, course content. Yes, course content, course our content. Just you can go through the website here. Even little bit. Let me show that course content. So this is course content here. So first initially, yes, software basics and Java basics and coding skills. Initially, once you good at coding skills, then starting Java oops. Yes, after oops, next exception handling, then collection of framework, next input output streams, networking, and except yes, multi-threading, these things here. Yes, this here first 1 month focusing on coding skills. Next Java, main oops concepts and all that here. Apart from that, interview questions, test papers I'll be shared with you, daily class documents. Okay. So every day 5 to 6 programs I'll explain and 5 to 6 assignments. Yes. So 300 plus programs will be discussed by the time of finishing this course. 300 plus programs will be discussed. Okay. Yeah, I think that's all enough about all this here. Okay. So day 1, this is, yes, it is 75 days. Course hours 75 days. Okay, daily 1.5 hour class, 7 to 8:30. Okay. Yes, still if you want more about syllabus, just you can visit Durga website here. Yes, Durga. Durgasoft new batches. New batches. Yes, go to here, new batches. Yes, search for Durgasoft new batches. Here, new batches. Open that new batches. Here, core Java by Mr. Nageswar Rao. Course content. Here, course content. Course content. See, this is the course content. Just go through that. Go through that all that contents. Okay, yeah, enough for today. Yes, so this is day 1. So day 1, repeat it. And next day to yesterday session. Yes, yesterday day to session Java overview. So what is Java? Java history. Yes, about Java content and all that here. Just to Java overview given. Java overview. Just it's only overview. Of course, this will be repeating once again. This overview will be repeated again. Don't worry, guys. This overview will be repeated. Okay, just only overview. Yes, explained about yes, Java, different editions. What is standard edition? What is enterprise edition and migration effects? These things just explained. Yesterday, these things were explained. Okay, just it's a overview. Just it's a overview. Okay. So here about course discussed last 2 days. About course explained. Next Java overview given. Today we'll start actual classes. Today starting now classes. Yes, so today starting from the beginning subject. Yes, starting from the basics. Starting from the basics. Okay, here today starting from the basics here. Yes, here I'm not expecting any IT backgrounds. So without any IT backgrounds, without any yes IT background, without any IT backgrounds, also you can understand here. Without any IT background, also you can understand. You can understand. You can understand. Without any IT background, also you can understand here. Okay, I'll start from the basics. Start from the basics here. So finally taking to high end. Finally taking to high end. Taking to high end. Taking to high end. Okay. Yeah. So before going to Java, there are some software basics. So before going to Java, there are some software basics. Yes, if you good at that basics, then easy to understand Java. Then easy to understand Java. Yes. So before going to Java, there are basics like yes, about OS operating system, about operating system. Yes, about operating system. Okay, next about yes, interpreter and compiler, about interpreter and compiler, about operating system, about interpreter, compiler. Next about exe files and about dot class files. Okay. Next about yes, languages like low level languages, yes, high level languages. Next about front end and back end softwares. Yes, and all the basics we'll discuss. So first I'm starting with these all the basics here. First I'm starting with all the basics. Once it completed, we'll start Java. Once it completed, we can start Java. Right? Yes, to understand Java, some basics required, like about voice, yes, understanding about voice, interpreter, compiler, all these basics. Once it completed, I'll start Java. Yeah, these basics, I think today, tomorrow enough. Today, tomorrow, all the basics, yeah. Day after tomorrow, starting Java. So today, tomorrow, all these software basics. Yes, let us start from the basics here. Let us start from the basics. See, computer where? So computer where? Computer. Yes, computer where? Yes, here computer where? So basically two categories in computer where? Computer where? Yes, two categories. Two categories in computer where? So first one hardware, second one software. Yes, computer where basically two categories here. First one hardware, next one software. Hardware and software. Yes, here what is hardware? Hardware, so these are physical components of computer. Hardware is a physical components. They are physical components of a computer like keyboards, mouse, monitor, hard disk, and all this comes under hardware, but not necessary for us. It's not necessary for us. Okay. Yes, we are not a hardware engineers. It's not necessary for us. Yes, we are the software. So let us start with software here. Software. Yes, software. So what's a software here? Software. Yes, software. See, today started from the basics. Okay, so previous, yes, last two classes, just a course introduction discussed, nothing, leave it. That is not necessary. Last two classes, nothing discussed, not necessary. Today started subject. Today started subjects. Yes, from the beginning, from the basics. Okay. Yes, computer ware, two categories, hardware and software. Hardware, these are physical components of a computer. These are physical components of computer. 1 second. Hello. Experience. Oh, sorry. Okay. Okay. Yeah. Software. So what is exactly software? See, software, yes, in software, yes, everything is a program. Everything is a program. Everything is a program. 1 second. Yes, you guys, running notes is not necessary. I have prepared the document. Well prepared document is available. Let me show that document. You guys need not feel any tension. It's not necessary. Just to try to understand classes here. Okay, well prepared document is there. Here, well prepared document available. Yeah, this is, yes, introduction to software. Yes, from this I'm start. From the basics. So these all these software basics here. After finishing software basics, then we'll go to Java. So these software basics you must have. You must have this knowledge here. After then you have starting about Java. So before going to Java, there are some software basics like interpreter, compiler, next about, yes, low level languages, high level languages. Okay, so there are some basics. Next about front end, back end. Next about web application. Next front end software, back end softwares. Next about your operating system. Next system software, application software, all the basics here. So once you good at basics, then easy to understand Java. So once you good at all these basics, then easy to understand Java here. Yes, even non-IT background students also can understand my classes very clearly. Non-IT background students also can understand it. My topics like the spoon feeding, anyone can understand. Repeatedly, I'll explain it. Topics repeated 2 to 3 times, I'll explain the topic. Okay, right? Yeah. So try to focus on the class. Don't write any class notes. It's not necessary here. Okay. Yes. Still recording is available. Yes. Now present recording is going on. That record will be shared with you. That recording shared with you. And also this document I'll share with you. This main document. Your daily class document. I'll share with you. Yes. See, my class order and this document order both are same order. No changing in order. Same order. As this, you can go through the document. Enough. Okay. So don't write any running notes. Try to understand concepts very clearly. And if time available, then watch recordings. Recordings will be shared to your Gmail ID. Okay. Yeah. Yes. So let us start. Yes, I'm starting from the computer basics here. So computer where there are two categories. First one hardware. Next one is software. Okay. Yes, software. Yes, hardware, these are physical components that is not necessary for us. Next is software. See, software. Yes, in software, everything is a program. Everything is a program. Yes, it's a collection of programs. Yes, it's a collection. Yes, it's a collection of programs. Software, it's a collection of programs. The software, everything is a program, it's a collection of programs. Okay, here software, basically, basically two categories. Software, basically two categories. Software, basically two categories. Software, basically two categories. First one, system software. First one, system software. Second one, yes, application software. System software and application software. Okay. Software basically two categories. Software, yes, computerware means the hardware and computer software. Those things called as computerware. Yes, is a computerware means is a combination of hardware and software. Hardware and software is a computerware. Okay, right? Yes. Software basically two categories here. Yes, in this application system software and then application software. Software basically two categories. One is system software, another one application software. Yes, what is system software? Yes, there is in software, there is a system software and application software. System software. So what is system software? System software, see it interacts. Yes, it interacts with the hardware components. It interacts with the hardware components. It interacts with hardware components. A software, it interacts with hardware components. Software interact with hardware components. Okay. System software, it interacts with hardware components. For this example, OS, operating system. So operating system interacts with the hardware. Operating system. So operating system comes on this category here. OS interact with hardware components. Okay. So system software, it's a software which interacts with hardware components. So OS is an example of system software. OS comes under system software. Operating system, like Windows OS, Linux OS, those operating systems. Next, application software. So what is application software? See, application software. So this is for the purpose of application development. Application software. Yeah, this is for the purpose of application development. For the purpose of application development. For the purpose of application development. So application software. Secret application software. This is for the purpose of application, yes, development. For the purpose of application development. Okay, application software for the purpose of application development. Applications, apps. See, in our daily life, we are using many applications, right? In our daily life, we are using many applications, working with many applications. For example, in your mobile, there are many applications, right? In your mobile, there are many applications. Yes, which is mostly used application in your mobile? Which is mostly used application in your mobile? Yes, anyone can you answer this? Which is mostly used application in your mobile? Anyone? Which is mostly used application in your mobile? WhatsApp. Good. WhatsApp. Yeah, WhatsApp. So, Chandra, obviously it's a WhatsApp. WhatsApp, right? So, WhatsApp is a most used application. Next, Facebook. Yes, is these applications. WhatsApp, Facebook. Okay. Yes, next, online trading applications. Yes, online. Yes, online trading. Yes, online trading apps here. Online trading applications, WhatsApp, Facebook, online trading applications here. Next, banking. Yes, banking apps. Okay. So banking apps, yes. WhatsApp, Facebook, online trading applications, banking applications. Okay. Yes. Yes, apart from this, yes, like suppose some Flipkart application, Flipkart. Some Flipkart. Like this, there are many applications, even Zoom also application. Okay, right? Yes, like yes, GPay, Google Pay, like Phone Pay. So these are all of the applications, right? All the applications. Okay. So application software is for the purpose of application development. Apps. These are the applications. So these are the applications. To develop this kind of applications, we can use application software. So to develop this kind of applications here, maybe food delivery applications here, online trading applications, okay, Amazon services and all that, Zoom application. Like this, there are many applications. Yes, to develop this kind of applications, we can use application software. Yes, application software, best example, Java. Java is a mostly used application software. Java is a mostly used applications. Java is a mostly used applications of Java. Next, .NET is also application software. Next, C and C++ is also application software. Next, databases. Databases also application software. Suppose Python. Python is also application software. Like this, there are many applications softwares. Okay, many application softwares. Like, see, in software, we are using many things, many technologies. In software, many technologies. More than 100 technologies we are using, more than 100. Okay, like, yeah, there are some languages we are using. There are some languages. There are some languages. There are some tools using it. There are some packages. Like there are many things, right? Languages. Language like Java, C, C++. Tools like testing tools, big data processing tools, reporting tools. Like there are many tools. Next packages like ERPs like that. So there are many things we are using, right? Many things. Okay. So exactly which is application software? So exactly, yes, there are many things in the market here. Yes, in software world, we are using many technologies. So which is exactly application software? See, OS can interact with hardware components. Only OS comes under system software. OS is a system software. OS is a system software except OS. See, except operating systems. Except operating systems, yes, remaining all are application software. Except OS. Except operating systems, remaining all are application softwares. All are application softwares. All are application softwares. All are application softwares. See OS. Yes, see except OS, except operating systems. Except operating systems. Yes, remaining all are application software. Remaining all are comes on application software, right? See OS. See OS some examples. Yes, you guys can you tell me what are the operating systems? Yes, what are the operating systems known for you? Tell me operating systems. Yes, operating systems. Yes, no one. Yes, you can ping in chat box. Yes, operating systems. Yes, operating systems. Examples. Yes, Windows is a OS, right? Windows is a OS. Next, Linux is a OS, right? Yes, Windows is OS, Linux is OS, Unix is also OS. Like there are different operations, like Mac OS is a Mac. Okay. Next, in mobiles, we are using Android OS. Next, iOS, these are all the operations, right? Like there are many operations, like Solaris. Yes, like Solaris is also OS. Solaris. Okay, Solaris. Next to IBM AX, HP Unix. Like that, there are many operating systems. So these are operating systems, right? Except operating systems, remaining are application software. Yes, OS and application software. That's it. See, everything running on top of OS. Suppose Windows based on top of OS, all are running, right? Maybe Java running on top of OS. Yes, suppose take some tools. Tools running on top of OS. Maybe AWS tools, DevOps tools here. Maybe any application building tools, testing tools. Okay, maybe some languages, maybe some packages. All are running on top of OS. So these all are running on top of OS, right? Okay. So OS is a system software. Except OS, remaining all are application softwares. Okay, fine. Yes, let me review today's topic. See, computerware. Yes, it's a combination of hardware and software. Computerware, it's a combination of hardware and software. hardware. These are physical components of a computer. These are physical components of a computer, but not necessary for us. Not necessary. Next year, software. Software. Yes, we are software engineers. Let us see about software. See, in software, everything is a program. Everything is a program. Yes, it's a collection of programs. Software is a collection of programs. Software basically two categories. Software basically two categories. First one, system software. Next one, application software. System software and application software. See, system software. This one interacting with the hardware components. In software, system software and application software. Here, system software, it interacts with hardware components. Interacting with hardware components. Example OS. OS is a system software. Next, application software. So this is for the purpose of application development. So these are using like Java, .NET, C, C++, all they are using to develop the applications like WhatsApp kind of application, Facebook application, online trading applications, banking applications, maybe Zoom. Okay, that's online meeting application. Yes, Google Pay, Phone Pay, and all these this kind of applications. To develop this kind of applications, we need some software. That software is application software. Yes, application software, best example Java. Java is a mostly used application software. Java is a mostly used application software. Yes, apart from .NET and all this, right? See, except OS, remaining all are application softwares. Except OS, remaining all are application softwares. Now let us see about OS. What is OS exactly? Yes, about OS. The topic is about operating system. Here some question for you guys. Some question for you guys. Yes, can we run any program without OS? That is question. Yes, simple question. Can we run any program without OS? Yeah, Harshavardhan, okay, fine. Hafra Fatima, okay, fine. Next, any others? Yes, here can we run any program without OS? Answer is no. Without OS, we can't do anything in your system. Yes, if no OS, no computer. Without OS, no computer. Okay. See here, in your computer, this is yes, this is a BIOS, except BIOS, except BIOS, except BIOS to run all programs. OS requires, OS requires, OS requires, except BIOS, except BIOS to run all programs. OS requires. What is exactly BIOS? BIOS. Anyone idea what is BIOS? Can you abbreviate here? BIOS abbreviation. What is BIOS? Yes, you can speak. Yes, anyone. You can speak or you can ping. See, BIOS stands for yes, basic, yes, basic input and output system. Basic input and output system. basic input and output system. So BIOS stands for basic input and output system. BIOS stands for basic input output system. Okay. Right? Yes. So BIOS. So BIOS stands for basic input and output system. Yes, what's the task of BIOS? Let me show that. Yes, in your system here this is a BIOS. One second. So this is BIOS. It's a BIOS in your system. Yeah, this is BIOS in your system. So what's the task of this BIOS? So what's the task of this BIOS? See, yes, when power on your system, so first of all, power goes to this BIOS chip. Here is a BIOS chip. So once you power on system, first of all, power goes to BIOS chip here. This chip code is one program, hardware program. The chip code is hardware program. Hardware program. Okay, the chip code is some hardware program. So hardware program, yes, BIOS is a hardware program. Hardware program. Yes, it's a chip level program. It's a chip level. It's a chip level program. It's a chip level program. Okay. Yes, BIOS is a hardware program. It's a chip level. Then what's the task of this BIOS here? So once your power on system here, first of all, power goes to BIOS. Now this BIOS is responsible. Yes, BIOS is responsible to boot your operating system. So your BIOS is responsible. BIOS is responsible to boot OS here. So your BIOS. So BIOS. So BIOS is responsible. BIOS is responsible. Responsible. Yes, to boot operating system. To boot operating system. To boot operating system. So your BIOS is responsible. So BIOS. So your BIOS is responsible to boot operating system. BIOS is responsible to boot OS. Okay, right? BIOS is responsible to boot OS here. So what is booting here? Yes, what is exactly booting? See, booting, yes, is a process. Booting is a process of loading OS from, yes, hard disk. Yes, from hard disk. Hard disk to RAM memory. Hard disk to RAM memory. Hard disk to RAM memory. Yes, booting. Booting is a process of loading OS from hard disk to RAM memory. See what happens here. Yes, OS inside the hard disk. See here, this is C drive, C drive, D drive. In C drive here, this OS, Windows OS, right? Windows OS storing inside the disk. Hard disk is for the storage. Hard disk is for the storage. Hard disk is for the storage. Okay. So here OS inside the disk. It's a Windows OS. Windows OS, all the Windows OS file system. Okay, Windows OS file system. Right? So this is in the hard disk. This is in the hard disk. So once you power on system, first of all, power goes to BIOS. Power goes to BIOS. This BIOS is responsible to load. Responsible to load OS from hard disk. Hard disk to RAM memory. Hard disk to RAM. So here BIOS is responsible for it here. So BIOS. So BIOS. So BIOS is responsible to boot OS here. Booting means booting is a process of OS loading OS from hard disk to RAM memory. Hard disk to RAM memory. See, now this OS, Windows OS, right? Windows OS running inside the RAM memory. So here it's a Windows OS. Here it's a Windows OS. This Windows OS running in the RAM memory. See, everything happens inside the RAM memory only here. So OS running in RAM memory. On top of OS, everything will be running. So OS running inside the RAM memory. Okay, right? So this is about BIOS. Okay, so BIOS. So BIOS stands for basic input output system here. So BIOS is a hardware program. It's a chip level. So this is responsible to boot OS, here. So booting process, booting. Booting is a process of loading OS from hard disk to RAM memory. So once booting is done, your system is ready. So once booting process completed, your system is ready. So you can now OS is ready, right? So you get this OS, Windows OS running inside the RAM memory. This Windows OS running inside the RAM memory. Okay, now system is ready. So system is ready, right? System is ready. Okay, now, so let us see about OS. What is operating system? Topic about OS. So what is operating system? Yes, about OS. So here, what is operating system? So what is operating system? See, let us see about OS. What is operating system? What is OS? What is OS? See, let us take computer. In computer, there are different layers here. Different layers. So here it's a hardware layer. First of all, this is a hardware layer. On top of hardware, OS is running. Yes, operating system. Yes, on top of hardware, OS is running. On top of OS, all programs like Java program running. Yes, C and C++ programs. Yes, maybe Python scripting. Okay, maybe databases. Okay, databases. Even for MS Office also OS required. Yes, all are running on top of OS. Even for MS Office also OS required. These all are running on top of OS only. So OS is on the top of hardware. Yes, your computer hardware on top of hardware. Means here's a RAM memory. Inside the RAM memory. Yes, inside the RAM memory, OS is running. On top of OS, all the programs running. These programs are called as application software. All these are application software. All these are application software. Yes, all their application software. Yes, it's application software. Okay. Yes, this is computer. In computer, here's a hardware. On top of hardware, this is OS. On top of OS, all the application software working here. See, OS is a system software. Here, OS is a system software. So OS is a system software. So OS is a system software. It's a system software. So OS is a system software. It's a system software. OS is a system software. See, hardware on top of hardware, OS on top of it, these things, right? This whole thing is a computer. Computer. See, previously, yes, computer were right. There are two things, hardware and software. Yes, hardware, software working together is a computer. Computer where there are two things like hardware and software. In computer where hardware and software. Hardware, software. See, here's a hardware layer, on top of it, software. Here, hardware, on top of it, software. This is our computer. Our computer. Okay, so hardware. So these two layers is software. See, in software here, there are two things, system software and application software. In software, again, two layers like system software, application software, system software, application software. See here, system software and application software. So these two, it's a software layer. This is a hardware. This whole thing is computerware. That's it. I hope you understand that. Computerware. This whole is a computer. Yes, in computer, there is a hardware and a software. In software, there is a system software and application software. So you get system software interacting with hardware. Yes, OS interacting with hardware components. System software always interact with hardware. So OS comes under system software. So only OS can interact with the hardware. Okay, fine. See, on top of OS, all programs running here. Suppose Java program running on top of OS, C program, C++. So whatever the technology we are using software field, all technologies running on top of OS. All technologies, maybe some languages, maybe some tools, maybe some packages, whatever technology coming here, all technology is running on top of OS only. All technology is running on top of OS. Okay. Yes, here, yes, this application software through the OS it can communicate with hardware. There is no direct communication. No direct communication between application software and hardware. So application software never interacting with hardware. Never interacting. Yes, through the voice. Interacting through the voice. Here, what happens here? Suppose, for example, here, Java program generating some output. Output of Java program, first of all, transfer to voice. Output of Java program or C, C++, output of all the programs. Output of all the programs, first of all, transfer to voice and then finally deliver to output device. Deliver to output device. Suppose input data, keyboard. Yes, keyboard. Suppose keyboard data simply goes to voice and then transfer to your Java program or C program, C++. Okay. So here application software directly cannot interact with hardware. So between application software and hardware, there is a voice. Okay. So all these programs, all these application software is running on top of OS. On top of OS, all are running, right? So OS acting like a platform. OS is like a platform. OS is like a platform. On top of it, all are running. On top of OS, all are running, right? So what is OS means? OS, yes, it's a platform. Simply we can say it's a platform. Yes, OS, yes, it's a platform. Yes, OS is a platform. Yes, OS is a platform. Yes, where we can run. Where? So OS is a platform. OS is a platform. OS is a platform. It's a platform where we can run all application software. All application software. All application software, right? Yes, it's a platform. So OS is a platform. So OS is a platform. So what is operating system means? It's a platform where we can run all the application software on top of OS. All application software is running, right? So acting like a platform. So OS is acting like a platform, right? See, not only platform here, not only platform. Suppose Java program delivering some output. First of all, output transfer to OS, right? And then deliver to output device. Suppose input. So first of all, input data goes to OS and then transfer to application software. So between application software and hardware, there is a OS, like a mediator. OS is like a mediator between application software and hardware components. Yes, mediator, exactly you can see the interface. It's an interface. So next point about OS, yes, it is an interface. Yes, it is an interface. It's an interface. It is an interface. Yes, between application software layer. It's an interface between application software. It's an interface between application software and hardware components. And hardware components. And hardware components. And hardware components. Okay. Yes. It's an application software and hardware components. Yes, it's an application software and hardware components. Okay, right? Yes. So same topic I have prepared in document here. Yes, same topic I have prepared in document. Let me show in the document here. Yes, let me show in the document. Yes, today topic. Today started. See, yesterday's class just about course introduction given. About course information explained. Just only course, nothing here. Today started actual subject. Today's subject started. Yesterday session just only course overview explained. That's it here. Course information, that's it. Subject today started. Subject, today's subject started. So today first class subject, first day in the subject here. Yes, today started from the basics. So first introduction to software. So before going to Java, there are some software basics. See, today new guys. Today any new guys, don't worry about yesterday's session. Yesterday's session, just only course information explained, like about course duration, course fee, next about myself introduction, course content, and all that explained here. Don't worry about it. Okay, that is nothing here, simple. Yes, today started actual topic. Today started actual topic. So started from the basics. So before going to Java, there are some software basics. Before going to Java, there are some software basics. Yes, today started software basics. Yes, today topic. Started from the basics here. Yes, computerware. This is a hardware and software. Computerware, it's a combination of hardware and software. Computerware, it's a combination of hardware and software. Hardware, these are physical components of a computer. Hardware is a physical components of a computer. Okay, but not necessary for us. About hardware, not necessary for us. Yes, topic is about software. We are software engineers. We are software. Let us start with software. Software. In software, everything is a program. In software, everything is a program. Yes, it's a collection of programs. Yes, software, everything is a program. It's a collection of programs. Software basically two categories. Software basically two categories. First one, system software. Next one, application software. In software, there is a system software and there is a application software. Yes, system software, it interacts with hardware components. It interacts with hardware components. Example OS. OS is a system software. Yes, application software. This is for the purpose of application development. Application development. Yes, applications like WhatsApp, Facebook, online trading applications, banking applications, Flipkart, Zoom, yes, Google Pay, PhonePe, and all their applications. To develop this kind of applications, we need some software. That software is application software. This applications development, this kind of applications. Best like some Java. Java is application software. .NET, C and C++, all their application softwares. Yes, 1 second. See, except OS, except operating systems, remaining all are applications. Except OS, remaining all are application softwares. Okay. Yes, OS like Windows, Linux, operating system, right? Except these things, remaining technologies. In software, there are many technologies we are using here. Software, there are many technologies. More than 100 technologies we are using, right? All are application software except OS. Except OS, remaining all are application softwares. See, let me show document here. Today class document. Yeah, this document for you only. Yes, this will be shared. Okay. Yes, today drive access will be given to all paid students. Yes, online team. Yes, online team will give the access to all paid students here. Yes, so that paid students getting this document. Yes, it's a 900-page document. Your daily class document. See, it's a daily class document. Today's topic, introduction to software. Software is a collection of programs. Okay. Software basically two categories: system software and application software. See, system software, it interacts with hardware components. Example ways. Application software for the purpose of application development. Same topic explained here. Yes, in Notepad, same this topic explained. Next about ways expand here. Yes, see, can we run any program without ways? No. Same here. Same in Notepad. Same thing expand here. Yes, about bias expand here. It's there in document here. Just you can follow document here. Same points. Same points expand here. Okay, just you can go through the document here. After finishing class, just you go through the document every day. See, my order of explanation. See, for explanation purpose, here I'm using Notepad. Sometimes Notepad, sometimes Word document, like the different kind of things I'm using to explain the class, to explain your topics. So whatever things expand here, same thing you can see in the document. My order of explanation and document order is same order as is here. Yes, all are prepared in the document. Just you can follow document, nothing missing here. Every line will be there. Every line. See about ways. It's a platform where we can run all the application software, right? Next is an interface between hardware and application software. Same thing expand here. See this OS. Hardware here, this is a hardware. On top of hardware, this is a OS. On top of OS, application software, right? Here, this is a hardware. On top of hardware, this is OS. Okay. On top of OS, here, this is a application software. Same thing expand here. Yes. From this discussion, what is Java here? Java comes under what? What is Java? Yes, is it system software or application software? Tell me, what is Java? System software or application software? What you understand from explanation? What you understand? Yes. So what is Java? Finally, what you understand? Java is a application software, right? Java comes under application. Java is application software. Java is application software. Now topic is about application software. Java is application software. Yes, let us start topic. Yes, about application software. Yes, in application software, there are two things like front-end software, back-end software is there. In application software, there are two things, front-end, back-end. Front-end, back-end. What is front-end, what is back-end? Let us see. See, this is web application architecture. Yes, it's a web application architecture. Web application means application which is running on the internet is a web application. Web application running on the internet. Internet is a web application. For example, Zoom running on the internet, right? It's a web application. WhatsApp, web application. Facebook, it's web application. All the web applications, right? Yes, in web applications here. Yes, why these guys are disabled, have disabled pen and all this? Okay. Okay. So web application here. 1 second. So this part is a front end. Next, another part, back end. There are two parts in the web application. This is a front end, this is a back end. So front end means what we can see. What we can see is a front end. So front end always interacting with users. Front end interacting with users. Let me show that. Front end interacting with users. For example, front end example. See, here it's a form, right? Yes, I think today you have filled this form. Today you have filled this form, right? Yes, first name, last name, email address, okay, right? Phone number, something. So the registration form, right? Yeah, this form is a front end. So we are filling this information, right? This form is a front end. This form is a front end. Okay. Suppose, for example, Zoom sign in. Yeah, this also front end. Yes, Zoom login. Here, yes, home. Here I'm checking for my profile. So profile information here. Zoom login profile. So this is front end. Yes, your Facebook profile, right? That's a front end. Okay. All this information, this is front end. So this is interacting with users. Front end interacting with users. Okay. Yes, registration form. So this also front end, right? So front end interact with users, front end interact with users. We are the users. We are the users here. We are the users. Yes, we are filling this form, right? So we are the user. So this is called as front end. Front end. Yes, it's called as front end, right? Next, back end. So back end is called a server side. Front end is a client. Front end is a client. Back end is a server side. Client and server. Client and server. Front end is a client. Back end is server. So front end. To develop the front end, like we need some HTML, CSS, JavaScript, these things. These are front end technologies. Front end technologies. Back end. In back end, there are two things like application and database. Application and database. Suppose, for example, here, registration form. Your registration form data, first of all, posting to that application, maybe Java application or .NET application, something like this. And that application will insert data into database. Okay, so this is what is happening here. So front end, that form data, registration form data posting to application, application will post data to database, right? So this is web application. Yes, in this, who are working on the front end? Who are working on the front end is a front end developer. Who are working on the front end is a front end developer. Who are working on the back end? In back end, there are two things: application database, right? Yes, who are developing application is the application developer. Who are working on database developer. So totally three roles. Totally here is a three roles. Totally three roles. So here is a three roles. 1 second. So one is front end developer role. So one is front end developer role. Yes, in back end. So this is here is a front end developer. So front end developer role. Next in back end, application developer, and then database developer. So there are three roles in this case. Three roles. Okay. So front end developer, back end application developer, and back end database developer. So there are three roles in this. Three roles. Yes. Who are working as all the three roles? Who are performing all the three roles here? Who are involving all the three roles is a Java full stack developer. Yes, Java full stack developer. Yes, Java full stack developer means, yes, they must have front end knowledge, Java programming knowledge, and database knowledge. Who are performing all three roles? Who are performing all three roles? All three roles is Java full stack developer. Java full stack developer. So front end knowledge, Java knowledge, and database knowledge. That is Java full stack developer. Okay. Now in this here, here, Java application, right? Java application comes here. Java here, right? So what is Java here? Java is a backend application software. Java is a backend. Java working at the backend. So Java is a backend. Okay, right? See, here Java is application software. In application software, they say front end, backend. Java comes under backend. So Java comes here, right? I hope understand here. Java is a backend software. Java is a backend software. So Java comes under backend. Yes, see this. Java is a backend server-side programming to develop server-side applications. Java is a backend software simply. Java is a backend, not front-end, it's a backend. Java is a backend. Okay, fine. Yes. So Java is a application software. So this is comes at backend application software. Java is a backend application software. Java is a backend application software. Okay, fine. Now, front-end backends. There are two things like language and packages. Yes, in software here, there are two categories again, like language and packages. Packages, ready-made one, like MS Office a package. Here, no coding in packages. Packages don't have any coding. Packages don't have the coding. Like MS Office, no programming. ERPs, no programming. Okay. Yes, language. Yes, Java comes and language. In language, everything is code. In Java, so Java is a language. Java is a language. Java comes and language. Now, let us say our topic is about languages. Yes, about language. Language. Yes, topic is about languages. Topic is about language. See, languages. Language is a media of communication, right? Language is a media of communication between two things. Language is a media of communication between two things. That's okay, fine. Yes, in software languages, first one, yes, computer. Computer, yes, understandable. Computer, understandable language. Computer, understandable language. Okay, second one, yes, user understandable language. User understandable. User understandable. Computer understandable language. Next, user understandable language. So okay, there are two things here. So one is computer understandable language, another one user understandable language. Computer understandable language. See, computer understanding some language. We are understanding some language. Our language is user understandable. See, computer understandable language. Computer understandable language. Yes, computer understandable language. This one, computer understandable language. Yes, it depends on. Yes, it depends on generation of computers. Depends on generation of computers. Generation of computers. It depends on generation of computers. Yes, tell me, guys, how many generation of computers? Anyone idea? How many? How many generation of computers? How many generation of computers? How many generations? Yeah, 5 generations. Good. Yes, Fatima and us. What 5 generations? There are 5 generations. Like first generation. First generation, it's a vacuum tubes based. Vacuum tubes. Yes, based computer. Second generation. Second generation. Yes, first generation vacuum tubes. Second generation transistor based. Transistor based. Second generation transistor. Okay. So maybe yeah, transistor based. Transistor based. Third generation. Third gen is a yes. IC based. IC means integrated circuits. Integrated circuits, not computer. IC based. IC based. Integrated circuits. Next, fourth gen. Fourth gen is a processor based. It's a processor based. Now this is present gen. Presently we are using processor based. Yes, presently we are using processor based. So this is present generation. It's a present generation. It's a present gen. Now this is present generation. Okay. Yes, next 51. Yes, it's a future generation. Fifth gen is a future generation. So what is future generation in computer? AI based. AI based. Okay, future is a AI based computers. AI based computers. Now presently it's a processor based. Presently we are using processor based computer. See, processor based computer. Computer understandable language. Understandable language. Language is binary codes. It's a binary codes. Yes, processor based. Processor based. Processor based computer understandable language is binary code. So binary code is something like a zeros ones format. Binary code is like a yes, binary codes. Yes, it's a zeros ones format. It's like a zeros ones format. Zeros ones format. Binary code. It's like a zeros ones format. Yes, about this binary codes. Once Java program started, I'll explain. Yeah, Vanita, once session completed, I will talk to you. Okay. After finishing session, yes, I will talk to you. Don't worry. One session completed, I will talk to you. Just wait. Vanita and Harshavardhan, both guys. I'll talk to wait for some time. I'll talk to you. Okay. Yes. So processor based understandable language binary codes. So this is zeros ones format here. Next. So this is present generation. Future A. A. So what is A based? Yes, A based computer understandable language. A based computer. Yes, understandable language. So what is A based computer understandable language? Anyone idea? AI based computer understandable language. What is AI based computer understandable language? So what is AI based computer understandable language? Yes. So what is AI based computer understandable language? See, AI based computer understandable language, it's English. Yes, it can understand our English. See, AI based. Yes, Shravan saying that ML. Okay. ML and next Python, Java, all these are working in the backend data processing. That AI based computer, there is a backend. In backend to process the data using some language like ML, machine learning, next Python, Java, all these languages, backend. Only these are for the data processing. For data processing, yes, AI machine, backend is a data processing. For data processing purpose, we are using ML or Python or Java. But it can understand our English. AI-based computer can understand our English here. So what is AI here? So what is exactly AI? Artificial intelligence. Yes, artificial intelligence. Yes, AI is a, yes, let me explain something about AI here. AI is a technology. Technology. Yes, AI is a technology to make machines. Machines. Yes, working like a human being. Working like a human. Okay. So AI is a technology to make machines working like a human. Suppose in your home, there is a AI machine. In your home, some AI computer, AI based home. Yes. You can use simply instructions. In English, you can use the instructions. Yes, it works like your assistant. You can use the instructions like opening some door, closing some door here. Yes, washing machine on, off. Next, fan on, off. That if it is AI based home here, yes, it can listen our English. It can understand our English here. Yes, it will do all the works. Next, one more thing here. AI based computer can understand our English. Whatever is saying, it can understand. Yes, suppose if he's saying some stories, yes, it will listen for the story. It will remember. Okay, that AI based machine, yes, it can understand your story. Whatever is saying story, it will listen. Okay, and remember. Suppose in future, if you're asking any question from your story, it will reply immediately. Yes, question. If you're asking some question here, based on question, yes, backend. some programming language working, maybe Python programming, yes, maybe Java program, maybe machine like something working, it will process that, it will pick the answer and giving, right? That is AI technology here. Okay, right? Yes, it can take, yes, it can understand. See, AI, it will take voice data, and also text data. Yes, yes, AI machine will take your voice data, or suppose if you giving text data, it will take text data also. Okay, so AI machine that is working like a human, working like a human. You can utilize that AI computers for anything here, not only in your home here. So about driverless car, for example, yes, driverless car, yes, driverless car, driverless car, right? Yes, in USA, there is a Tesla car released that working without driver. That is AI based car, Tesla AI based car. Okay, yes, a Tesla car. Suppose if driverless car, if you giving some instructions, if we define some route, as per the route, the Tesla car go to required location and picking, maybe picking items or picking persons and dropping some, picking and dropping. That car will do without any driver. Driver is not necessary. Okay, right? Suppose car on the way. Yes, if in opposite direction any vehicle comes, it will take diversion automatically. That AI based car will take diversion automatically. So like a human being. So exactly working like a human being here. Yes, AI based to whom? Yes. Next, AI based car like this. AI based machines. Maybe manufacturing industry using AI based machines. That machines working like a human being here. You can talk to AI based machines in English. It can understand your English. Okay. Suppose in your home, you can chat with that AI based machine. It can respond. It will respond. Whatever he says, it will listen and giving response also. Yes, like a one of the family member, that AI-based machine working like a one of the family member, like assistant. Yes, manufacturing industry, they are also using AI-based machines. Okay, next driving vehicles using AI-based machines. Like all the areas involving that AI-based machines. Okay, so with the help of AI-based machines, yes, within short time we can finish the work. Within short time we can finish the work here. Okay, work transparency. Pollutionless world, even pollutionless world, you can see AI based world is a pollutionless and work transparency within time finishing. Okay, yes, here without hiring any workers, yes, you can finish your work with the help of AI based machines. That is advantage. Okay, so here within short time, within expected time, we can finish your works. That is advantage. But with AI based machines, suppose AI based world comes, some disadvantages. So AI based world disadvantage. Main disadvantage, yes, main disadvantage, human become laziness, right? Yes, we will become, yes, all the people become lazy people. Will become lazy because AI-based missions available. Will become lazy. Laziness. So getting that laziness. Okay. Yes, apart from that, see, loss of thinking skills. Loss of thinking skills. Because somebody is working for us, right? Then why thinking? Okay, loss of thinking skills here. If someone is working for us, then why thinking? Is not necessary. Okay, loss of your thinking skills. Okay, so your intelligence degrading day by day. Yes, intelligence. Yes, intelligence degrading here. That intelligence degrading day by day here. Okay. Yes, intelligence. Yes, degrading. Okay, right. Next, one more dangerous. One more dangerous with AI-based world. One more dangerous thing here. Everything is under the control of machines. Yes. Now presently we are controlling everything, right? Yes, as a human, we are controlling all the machines, right? We are controlling all the machines. But once AI-based world comes, that AI-based machines will control us. So everything goes under control of AI-based machines. That is dangerous with AI-based machines. Yes, future, maybe after 10 years, by 2035, yes, maybe AI-based world you can see. Yes, AI-based world. By 2035, you can see AI-based world. Yes. So 10 years, within 10 years, we can see that AI-based world. Okay, right? Fine. Now here in this language here, computer understandable language, user understandable. Yes, computer understandable language called as low level language. It's a low level language. Computer understandable language is a low level language. It's a low level language. It's a low level language. Computer understandable language is a low level language. Low level language, right? Second one, user understandable is a high level language. Low level and high level. Low level and high level language. So in software, there are two categories of language here: low level and high level languages. Low level and high level languages. Low level and yes, high level language. Yes, 1 second. Yes, low level and high level language. Low level, yes, it's a system understandable language. Low level, yes, it is a system understandable language. Low level, yes, it's a system, it's a computer here. It's a system understandable. It's a system, yes, understandable. It's a system understandable language. It's a system understandable language. Yes, system means processor. Processor. Now, presently we are using processor based. Still AI based computers not using here. Still not yet here. Little bit came, but not completely here. Now, presently processor based computers. Yes, low level language. It's a system understandable language. Right? System is processor. Yes, processor. Yes, it is in the form of binary code. It is in the form of binary code. It is in the form of binary codes. Okay. It is in the form of binary codes. Okay. It is in the form of binary code. Okay. Binary code like zeros, ones form binary codes. Yes, it is called as machine language. Yes, it is called as machine language. It is called as machine language. It is called as machine language. Okay. So next one, high level language. High level language. Yes. What is high level language? Yes, it's a user understandable language. It's a user. It's a user understandable language. It's a user understandable. It's a user understandable language. It's a user understandable language. Yes, it is like English. It's like English. Right? Yes, high level language examples. High level language examples. Examples. Java is high level language. Next C and C++. High level language. Python is high level language. They're high level language. All their high level language. Okay. So Java, C, C++, Python. So these are high level language. Java code looks like English. C programming, C++ looks like English. Python code looks like English, right? So these are high level language. Okay. So in languages, low level language and high level languages. Low level language, it's a system understandable language called as machine language. Machine language. Next, user understandable language. Like Java, C, C++, and all these are high level language. Yes, here, once again, system cannot understand Java. Your computer cannot understand Java. Java program, C, Python. So they're high level language, right? System cannot understand this high level language. Yet that high level language has to convert into binary code, system understandable language. High level language to binary code. Binary code means system understandable language. Which one will convert from high level language to binary code? Anyone can you answer this? There are some tools. There are some tools to convert from Java to system understandable language. C program to binary code. Python to that binary code, right? So from high level language to binary code, which one will convert? Good. Harshvardhan, good. Yes, either interpreter or compiler. Yes, either interpreter or compiler, either interpreter or compiler. Yes, either interpreter or compiler will convert from high-level language to binary code. Yes, what is interpreter? What is compiler? About interpreter and compiler, we have to discuss. So this topic tomorrow we'll discuss. Tomorrow we'll discuss. Just wait for some time. Today topic. So this is today topic document here. I'll share with you these documents. So this is today topic document. Okay, like low level, high level languages, like generation of computers here. Okay, about low level language, about high level language, and all that expansion. Yes, interpreters are compilers to convert from high level language to binary codes. High level language to binary codes. High level language to binary codes. Okay, high level language to binary codes. Okay. Yes, high level language to binary code. 1 second.